In this video, we're going to use a fifth method to show how you can prove identities. So we want to show the tangent of negative x times cosine x is equal to negative sine x. Now, whenever you see a negative angle, like you do right here, in a trig identity, this is your light bulb moment that you should think, oh, I need to use even and odd properties in order to prove this identity. And with the even and odd properties, recall that all trig functions, with the exception of cosine and secant, are odd functions. And that tells me that tangent of negative x is equal to negative tangent x. Cosine and secant are even functions, but all other trig functions are odd. So I'm going to replace tangent of negative x with negative tangent x, and I still have to multiply that and bring down my cosine x, and I'm trying to show that the left-hand side is equivalent to negative sine x. So now I'm going to pull in our first method that we talked about and translate my expressions into terms of sine and cosine. So tangent, I can use our quotient identity and rewrite tangent as minus sine x over cosine x times, bring down my cosine x, and I'm going to write that over 1 so my fractions line up. So now I have a cosine on the top and the bottom I can get rid of because that will be a factor of 1, right? Cosine divided by cosine is 1, and I'm left with minus sine x is equal to minus sine x. So we just showed how we can use even and odd properties to prove an identity. Okay, in our second example, again, I see here that I have a negative angle. So that tells me bells and whistles should go off, and I should think about using even and odd properties to try to prove this identity. So recall that all trig functions, with the exception of cosine and secant, are odd. Cosine and secant are even functions. So that tells me that cosine of negative x is simply equal to cosine x. So I can replace cosine of negative x with cosine x. So I have 1 plus cosine x times 1 minus cosine x, and I want to show that that's equal to sine squared x. Now from here, I'm just going to FOIL or distribute. So I have the 1 times the 1, which gives me a 1. And then I have the 1 times the minus cosine. That gives me minus cosine x. And then I have plus cosine x. And then minus cosine squared x. And I'm still trying to show that that's equal to sine squared x. I have a minus cosine and a plus cosine here. So those drop off because those add up to 0. So I'm left with 1 minus cosine squared x is equal to sine squared x. Now, if you think back to one of our key Pythagorean identities, we have sine squared x plus cosine squared x is equal to 1. If I subtract cosine squared x from both sides, this is what I get. So I know I can replace the 1 minus cosine squared x with sine squared x. And we are done. So the main idea is if you see a negative angle in your identity, you want to use the properties of even and odd functions in order to prove that identity. And then keep in mind that all trig identities are odd except for secant and cosine. Those are even.